Hello and welcome to episode 5 of the Flexibility Focus podcast. I hope you are safe and well wherever you are in the world as you're watching this installment of the show on YouTube or Instagram, or if you're listening to the audio version on your favorite podcast app. I know it's been a little while since I released one of these, but lots of stuff has been happening. The most notable being that I finally launched my online course for coaches. It's called the Master Flexibility Trainer course, and it's a 16-week program which teaches you everything you need to know about coaching flexibility training to other people. I've been coaching people both offline and online since 1998, so I've been doing this professionally for over 22 years. I started offline coaching by teaching dedicated flexibility classes in the karate dojo where I trained. And I started online coaching by giving people advice in the earliest chat rooms and then forum message boards and over emails. There is a lot to the subject of flexibility itself. Contrary to a popular misconception, it is not just passive stretching, and there's also a lot to the subject of coaching flexibility. And this course I've created merges both of those into a single progressive learning program that covers all of the important competencies that a good flexibility coach should possess, including subjects like biomechanics, cell biology, neurophysiology, screening and assessment, sport and exercise physiology, psychology, and so much more. The first intake of learners started at the end of September, and they've just entered week 6 with 10 weeks left to go, and the feedback I've received so far has been nothing short of phenomenal. One of the comments I received just last week was that the depth of content and quality of communicating complex ideas into simple concepts was better than this person had experienced at university. And as an educator, that is probably one of the best compliments I could ever hope to receive. Of course, I'm not running the course to receive praise, but I am extremely proud of the course which is being produced, and I think it fills in a lot of gaps that exist between the actual science of flexibility and what most of the industry thinks or claims flexibility is. There are a lot of people out there misrepresenting the subject, and while I've seen flexibility misunderstood by large swathes of the health and fitness industry for my entire career, I think it's worse now than it has ever been. My aim with the Master Flexibility Trainer course is to raise the standard of flexibility coaching education, not only within the industry, but also within formal institutions. And my eventual goal is to establish the very first master's degree in flexibility training, much like we currently have master's degrees in strength and conditioning. So many people place the highest value on strength when it comes to motor ability development, but they fail to realize that flexibility precedes strength and is actually fundamental to the development of strength. And like the learners on the Master Flexibility Trainer course have found out, strength training, and indeed anything we do as human beings, is technically flexibility training. The next intake for the course opens at the end of January, so keep an eye out for announcements about that. You can send me a DM on Instagram. It's at flexibility.research, or send me an email to dan@flexibilityresearch.com to get advance notification when registration opens. I'm also going to be launching a series of mini courses, the first of which will be released at the end of November, and it's called the Fundamentals of Structural Kinesiology. It will essentially examine anatomy and physiology through the lens of human movement, with a substantial focus on joint structure and function, and it'll be a great gateway course for people who want to do the Master Flexibility Trainer course but who don't have any pre-existing knowledge, although you can apply to do that course regardless of your background or education. And it'll also be a good refresher for people who want to brush up on their anatomy and physiology knowledge but who want to learn how it applies to actual human motor function. Again, keep an eye out for announcements on social media, or get in touch to be notified early when that mini course is about to drop. In this episode of the show, we're going to look at a subject that interests many people, but there's not a great deal of readily available information to satisfy their curiosity. That subject is genetics and flexibility. Without doubt, one of the most common questions I have ever received in emails and at seminars is how much of flexibility is genetic. We hear people say all the time that they can't do something because it isn't in their genes, or that some star athlete can only do what he or she can do because genetics. Indeed, much of what we are as human beings, from what we look like to how we can move, is determined by our genetic code, which is called the genome. In the absence of advanced genetic editing technology that currently only exists in science fiction stories, your genome is completely out of your control, so you shouldn't feel bad if there's something you genuinely cannot do because of genetic limitations that you inherited from your parents. Of course, that is also not an excuse to be lazy, and in many cases of so-called genetic limitation, the person just needs to work hard to achieve a desired result. However, there's no escaping the truth that flexibility is a phenotypic trait. A phenotypic trait is simply a characteristic that makes you, you. It includes such things as your eye color, your height, your skin pigment, your hair color, your hair type, and also your flexibility in terms of how much flexibility you could ever hope to achieve, or your ultimate limit of range of motion, the rate at which you can develop your flexibility, which is kind of like a speed limit on how quickly you get more flexible, and also the rate at which you will inevitably lose some flexibility as you age and the effects of senescence take hold, and all of these things combine to make up your genetic flexibility potential. An important point to raise here is that phenotypic traits can be influenced by genetics and your environment, which is a field of study called epigenetics. And in traits like flexibility, it is almost always a combination of both your genome and your environment. This is because while yes, your upper limit of range of motion is determined by your DNA, flexibility also responds very specifically to training inputs. And if you live in an environment which is very conducive to training, then your chances of becoming more flexible will increase. This diagram on the screen is adapted from a post I put out on Instagram over a year ago, in which I discussed the fact that many coaches mistakenly believe that physically loading tissues is the primary driver of tissue adaptation and flexibility training. And in fact, you can apply this model to all methods of physical training, be that flexibility, strength, endurance, or anything else you can think of. Thinking only in terms of loading tissues is very myopic, in my opinion, because it doesn't consider the broader context of the human being in front of you and how things like their physical and social environment, their belief system, and their habits ultimately influence their physical actions, perhaps more profoundly so than how their physical actions might influence all of those other things. And so this hierarchical pyramid shows how each factor sets the foundation for the next layer, beginning at the bottom with the person's environment. Again, this means their physical environment, their societal and cultural upbringing, how their parents raised them, which will influence their attachment style and may lead to the person becoming overly avoidant or anxious, and so forth. These environmental factors heavily influence a person's mind, and it's their emotions, moods, needs, goals, and aspirations which drive their behavior. And yes, I know I'm an Englishman using the American spelling of behavior, but I prefer the American spelling. And it's the person's physical behaviors, what they do with their body, which provides the stimulus for adaptation, which we call loading. The forces from that loading are converted into biological and chemical signals by specialized cells like fibroblasts and myocytes, which then creates the necessary adaptations that we seek. So while this episode is principally focused on the genetic influence on flexibility, it's important that we don't neglect all of these other factors which come before tissue loading and which can have as much of an effect on the eventual outcome as does our genome. I say that environmental, psychological, and behavioral factors can have as much of an impact on flexibility as genetics because research indicates they are almost equal in terms of their influence on your eventual joint range of motion. We know from early studies on twins by the likes of Chatterjee and Daz, and more recently with a meta-analysis by Schutt et al., that as much as 50% of our flexibility is determined by our genes, which actually still leaves a massive amount of potential for developing flexibility through factors which we have some measure of control over, like the environment, our thoughts and feelings, and ultimately the actions we decide to take. Some of the genetic factors which influence range of motion include the shape of bones and how they fit together to form the articulations or joints, because there are movements and ranges of motion which are easier for women than they are for men, for example, because of anatomical differences in the pelvis and hips between males and females. You might get a female yoga instructor performing some incredible feat of contortion on Instagram, and you think, wow, I want to be able to do that too. And the yoga instructor might even sell a program which she claims can help anyone achieve the things she can do with her body. And so you think, great, now I have a way to be able to do that. Except if you're a middle-aged man with normal hips, or what we would consider to be normal male hips, then there is no way you're going to be able to do many of the things that the advanced yoga instructor can do by virtue of gender variations in hip morphology, which you can't do anything about unless you elect to have surgery. But I don't think any surgeon in his or her right mind will carry out such a procedure just because you want to be able to bend like a pretzel like your favorite yogi on Instagram. Understand that what I am not saying here is that all female yoga instructors are flexible only because of their hip structure, or that none of them had to work exceptionally hard to get to where they are today, or that their training programs won't work. I'm not saying any of those things. But what I am saying is that there are many people on social media, and it's not just female yogis, who are selling programs which they claim will work for everyone, when the simple fact of the matter is that individual anatomy says that it won't, and we cannot argue with anatomy. Muscle structure is another factor which is principally determined by your genome, and in this context I'm referring to such things as the number of sarcomeres in series, the rate at which new sarcomeres are laid down in response to stretch, and contrary to a popular myth doing the rounds on social media, skeletal muscles do respond to passive stretch by increasing fiber length, and also the rate at which sarcomeres are lost either during immobilization or as a result of natural age-related changes. The number of available sarcomeres affects the effectiveness of strength-based stretching interventions like isometric stretching, which would always be a cornerstone of effective flexibility training, but which become even more important as we age. Pain tolerance, which is the maximum amount of pain you can handle before you quit, and it's different from pain threshold, which is the point at which the onset of pain is first felt, is hugely important in flexibility training because a large body of research has shown that the sensory aspect of stretching dictates how much range of motion we can display to a large degree. There's also ample research showing that pain threshold and pain tolerance are dictated primarily at the genetic level, but they're also malleable, which means they can be altered through various interventions, and it's a change which occurs through a process called neuroplasticity. Finally, genetics has a large influence on connective tissues, which in turn has significant ramifications for the amount of range of motion we can display at each joint, and that is what we'll look at next. One of the most prominent genetic phenotypes affecting flexibility training is joint hypermobility. It's very important to understand that hypermobility and being more flexible than average are not the same thing. Hypermobility is caused by a connective tissue disorder which increases extensibility of the connective tissue elements within muscles as well as the capsules of joints, and although it is initially diagnosed by a cumulative range of motion score taken at various joints in the body, as well as testing the extensibility of structures like skin, it's typically confirmed by molecular testing. Joint hypermobility is classified into different subtypes, including peripheral joint hypermobility, or PJH, localized joint hypermobility, or LJH, and generalized joint hypermobility, or GJH, which is the most common. These are classified further still into asymptomatic, where a person has an unusually large range of motion but no secondary musculoskeletal manifestations like trauma, weakness, or bone and joint disease. Symptomatic, where there can be comorbidities like digestive problems, and they can also be syndromic, which means specific conditions like Ehlers-Danlos syndrome, Marfan syndrome, and Louis-Dietz syndrome, which are accompanied by a host of unpleasant systemic problems like severe pain and fatigue. These syndromes are usually a result of genetic mutations in the extracellular matrix. The extracellular matrix, or ECM, is the name given to the three-dimensional connective network which provides cells with the structural and chemical environment in which they perform their various functions. The ECM is made up of mostly carbohydrates, different proteins, and water, and it's absolutely fundamental to connective tissue in humans. The ECM also contains fibers made from the proteins of elastin and collagen, which gives it incredible tensile strength. There's more collagen in the human body than any other protein, and it makes up everything from bones, cartilage, tendons, and ligaments to our skin, blood vessels, teeth, and corneas. Collagen is very rigid and resistant to elongation. Elastin is another protein which accounts for around 5% of connective tissue content, and it provides structures like tendons with greater elasticity, which is the ability to return to its resting shape after it has been deformed by an applied force. Joint hypermobility disorders stem from genetic defects which affect normal collagen production rather than an excessive production of elastin. Many people hear the word elastin and mistakenly believe it means tissues are easier to elongate or less stiff, but elasticity and extensibility or stretchability are not the same thing. When collagen is not produced in the normal manner, stiffness or resistance to elongation diminishes, leading to greater extensibility of tissues that don't function optimally when they're able to stretch beyond what we would call normal limits. Some people, typically those who are very inflexible, may look upon joint hypermobility syndromes with envy, and they may view it as something of a gift, but given that collagen is involved in many parts of the body, including internal organs, then it can actually be a very uncomfortable disorder to live with, and more attention needs to be brought to the struggles faced every day by people living with conditions like Ehlers-Danlos syndrome, Marfan syndrome, Alport syndrome, and many others which people have probably never even heard about. So what are some practical considerations we can make for people who have or suspect they may have a joint hypermobility syndrome? Well, first of all, understand that a joint hypermobility syndrome is not a death sentence for activities that you enjoy or that you want to take part in. So much of the information which is available to people diagnosed with JHS is that they shouldn't do X or that they should avoid Y. Yes, in certain circumstances, some movements or activities are contraindicated, but we should be trying to modify or change a particular exercise where we can, rather than eliminating it completely. Telling people they can't or shouldn't do something robs them of their self-efficacy and sense of agency, especially when not every modification has been tried. Of course, it goes without saying that if you are under the professional care of a specialist healthcare practitioner who has told you not to do something, then this podcast episode does not supersede their instructions. Next, we should be utilizing isometric training with hypermobile clients because they're safe, they're low impact, they build fantastic mind-muscle connection, which people with a JHS will need, especially if their proprioception isn't great. And isometrics can also serve as a fantastic gateway for externally loaded movements later on. I think hypermobile people should also incorporate a fair amount of proprioception training because of the balance and coordination deficits I've talked about. This type of training includes activities like standing on one leg with your eyes open and closed. Again, these should be appropriate to the needs and current level of the individual person. We should also be trying to train within a reduced range of motion. A simple rule of thumb which I've worked by and which has produced profound results over the years with hypermobile clients is to always train strength exercises at a point which is around 20 degrees in from a person's maximum range of motion. So if a person can go 10 degrees into elbow hyperextension and that elbow is causing them issues, say they're constantly spraining it because they can't control their extension, then during their strength exercises I'll get them to come back to neutral and then come in again by another 5 to 10 degrees so that they're not even reaching full extension. And that will cause adaptive shortening of the muscle fibers, which will help serve as a restraint against them going into hyperextension in the future. It won't prevent it, but it reduces the number of times it happens, and pain also tends to come down too. And finally, at least in the beginning phases of training, hypermobile people should focus on closed kinetic chain exercises, which are exercises in which the distal segments of the body, like the hands and feet, are fixed and they're unable to move. Research has shown improved outcomes for hypermobile people when doing closed chain exercises compared to open chain. And this is a good starting point when introducing resistance training. However, remember the mantra of modify rather than eliminate. So at some point, you should at least try open chain exercises and see how the person responds to them. Because it may be that by doing the closed chain exercises, isometrics and so forth, that they've developed enough stability that the open chain exercises are now much safer. Okay, that is it for this episode on genetics and flexibility. I hope you enjoyed it. Let me know what you think by leaving a comment or send me a message. Until next time, stay safe and stay flexible.